Okay, but now it's time to look at how the attention function works. So how can we assign these weights to the elements in the sequence? And actually, there are various possible implementation for the attention. Here, I'm considering one of the most simple one, but also one that is very effective. So basically, here the attention is just a dot product. So you see that here in this example, you see the H0, H1, H2. These were the same H that we saw before in the encoder. And we want to compute the weights for these elements in this sequence. You see that the other input is the decoder state that here I call as t-1. So the way we compute the weights is just to do a dot product between these decoder state and every element in the sequence. Like here you have the decoder state, which is st-1, dot product with h0. Here you see the same decoder state, st-1, but now the element is h1, which is the corresponding one. And here again, st-1, same decoder state, but now the element is h2. And the intuition here is that the model will somehow learn that this dot product has to be high if the word is important. So the higher the value here, so given this is a dot product, I end up with a scalar, which is a number. So the higher this number, the more important is the word. But at this point, there is still one step to do because we have numbers here, but we want to normalize them. So we can come up with words. And as usual, as you have seen in the previous day, when we want to normalize some quantities, we can use the softmax. So at the end of the softmax, here we have these weights that are exactly the weights that we mentioned before. So all these weights are between 0 and 1, and they all sum up to 1. And if you remember, after we have these weights, what we want to do is to do this weighted sum. So we take these weights, and we now multiply by the corresponding h, so that if the weight is very high, I will get a lot of information from that particular h. So that's how I can selectively control which information to take. And I will come up with this final vector chi, which was the context vector. And the context vector is what we fed into the decoder. Okay, here I would like to show some visualization for attention to see that it is really working, and it works the way we explained. So here you have a translation task, but in this case, it's English to French. Before it was French to English. So in this English to French, so you see the input at the bottom, you see the output at the top, and you see these lines that represent where the attention is looking at every time step. So you see kind of the easy case at the beginning, like when we are trying to produce this article here, the attention is mostly looking at the corresponding article in input. So this is kind of the easy case. And same thing happens here with agreement, and so on. But here, you see one interesting case. Going from English to French, here we are inverting the order of the words, like European Economic Area will become the Zone Économique Européenne. And you see that attention is actually doing the right thing. Like when we need to, when the decoder is producing the word zone, which is the translation for area, is actually looking at the word area, which was later on in the input sequence. Economic, okay, is let's say in the similar position, and you see the same happens with the word European. So here the attention is looking at the correct word, which is European. And here you see another interesting example. Like in some cases, we have different number of words to express the same concept. Like here we have was sign, which will become a été signé. So now we have 3 words. And you see that when the decoder is producing the output a and été, is looking at the same word, which is mostly was. Well, you see, it's not perfectly just one word, but is mostly looking at the word was. And here, when it's producing été signé, is looking at the word sign. So again, we have a visual feedback that of what the attention is doing here. And we can see that it's really trying to correlate the input. So let's say what was the input sequence from the encoder with what the decoder is trying to produce, so the output. And it is interesting that we can apply attention not only on in natural language processing. We can actually have these multi-area examples. Like here, you may remember the caption generation task from the first presentation is the one where we had this woman that was throwing a frisbee, so we have an image, and we want to come up with the description of that image. And the model has to do that automatically. And actually, we can use a sequence-to-sequence model with attention, because the decoder will work in the way that you expect. You can see it here on the right. So the decoder is producing text. The difference is on the left. So here, instead of having the encoder that we saw before that was running over the input sequence, here we have some architecture. Here I'm not specifying that. It can be one of the architecture that you saw yesterday in the CNN day. And you see that this architecture is kind of is creating this embedded representation of this image, and that's actually what before was the internal state that I was giving to the decoder. Now I'm giving this embedded representation. But even more interesting, you see that attention can work in this case as well. And to give an example, like here you have the word boats, and what we expect is that when the decoder is trying to produce this word boats, is kind of looking at the part of the image where we have the boats. We can actually see this more in details with, well, the example that you already saw yesterday. So again, this is the caption generation, and you see the input here is this image. So the first image is the input here. And this is the output, the final output of the system. So the system should try to produce this, a woman is throwing a frisbee in a park. But what you also see here that is interesting is what is attention looking at when we are producing the various words. Let's focus on this case here. So here we are producing the word woman. And you see that the attention is really looking at the human figure here. It's a little bit looking at the child as well, but you get the idea. And while we move towards the frisbee, you can see that when it's time to produce the word frisbee, it is looking at the object, at the frisbee. So it is, again, doing the right thing. And while we move towards the word park, you see that now attention is looking at the background. So again, is doing the right thing. So you can see how attention can, it's really a key intuition in this field, because having the possibility to look at the input and on demand extracting the information that I really need for a particular state, it improves the performance of the decoder dramatically.